All right. So let's talk about some more of the details, um, of the F distribution, and let's talk about these degrees of freedom. So the degrees of freedom really aren't that hard to calculate manually. Okay, degrees of freedom of the numerator is just simply the number of categories that you have minus one. So that's very similar to um, with the chi-squared distribution um, when we were calculating goodness of, or not goodness of fit, when we were calculating independence. Okay. Um, Now, degrees of freedom of the denominator, also isn't that hard. This capital N is the total number of all sample sizes combined. So you just add all the sample sizes together, and that gives you capital N. And then you subtract from that the number of categories that you have. Okay. So that value isn't too hard to calculate, but that'll be something that your calculator will do for you. Speaking of which, that's kind of what I said here. The Texas Instruments calculator has an ANOVA function built in. Okay, so you hit the stat button, you go to tests, and it's the last one on the list. Now, the NumWorks calculator does not have a native ANOVA function. Okay. But what I've done is I've written a MyOpenMath question, which serves as an ANOVA calculator. Okay, an ANOVA function calculator. So it'll calculate the same things that this Texas Instruments ANOVA function calculates. Um, and I'll show the screenshots and an actual example of how to use it. Okay, later in 12.3. But for right now, these are screenshots from the Texas Instruments ANOVA function. So the first thing you have to do is you need to take your data. So you have multiple categories, and each category, is composed of numerical values. Um, and you put this in the list editor, not matrices, just the regular list editor. And when you run the ANOVA function, you'll actually type in L1, comma, L2, comma, L3, comma, L4, L5. Okay. And when you hit enter, then it'll do one-way ANOVA, and it gives you the test statistic, it gives you the p-value, and it gives you the degrees of freedom of the numerator. So remember, this is the number of categories minus one. So here, how many categories are there? There's 5 categories. So 5 minus 1 is 4. And then the error, okay, error degrees of freedom, that's degrees of freedom of the denominator, and it's 10. So remember, it's the sum of all the sample sizes minus the number of categories. So, here we've got 5 columns. Each column has 3, so that's 15 total. Adding up all the sample sizes, that's 15. And then 15 minus k, which is the number of categories. So 15 minus 5 is 10. So, you can kind of calculate this in your head. It's not any mystery here. But this one-way ANOVA does give you a test statistic and a p-value. And we've been using calculator functions for that forever. To get critical values, it's calculated using a non-native Texas Instruments program, Inverse F83, that I've put onto your calculator. It requires the significance level, degrees of freedom of the numerator, and degrees of freedom of the denominator. So you're going to want to run this first to get your test statistic before you get your critical value second. the numworks calculator does have an inverse F distribution built in. So you can get your critical value that way pretty easily. To calculate the mean of the F distribution, the mean is equal to the degrees of freedom of the denominator divided by the degrees of freedom of the denominator minus 2. The F ratio, okay, that's your actual test statistic that's being calculated. Now, the way it calculates the F ratio, okay, is really based off of all the values in this table. And you can see degrees of freedom of the numerator and degrees of freedom of the denominator are kind of a part of that calculation. So it's kind of like all these values are kind of working up to getting this F ratio, which is your F statistic. Okay. But we're not going to be calculating each of these values like this. We're just going to let the calculator do the work for us here. Okay. All right. So that's the end of this section. The next section will actually work through an example, and then there'll be a couple of examples for you to work through and try out. All right. Let me know if you have any questions.